Welcome to our class on creating an ability system with scriptable objects. I'm Matt Schell, and I'm going to be with you guys for the next hour. This is a sort of, I would say, intermediate scripting focused session, and it is the first of two sessions that we are going to cover this topic on. So the first one, we're going to work on setting up the kind of basic ability framework. And then in the second, we're going to add a character system and a character select, super simple character select menu. I have here a completed version of the project, which I'm going to walk you through and just kind of talk you through how it's set up. And this is the completed two-session version, and then I'll show you the part of it that we're going to cover this week. So we'll be covering the second part of this in 2 weeks at the same time on Monday, and that is on the schedule at unity3d.com/learn. And so a little kind of top-level idea about scriptable objects. If you haven't worked with scriptable objects before, what they are is they're another type of Unity script which is not a mono behavior. So they don't get instantiated in the scene, they don't get attached to game objects, they're not components, right? Normally most of the scripts we work with in Unity derive from mono behavior, and they're always going to be attached to something, right? But scriptable objects are not, and they can be created as standalone assets in our project, which is really nice, right? And it's particularly nice for things like data containers. Let's say we wanted to have a table of enemy stats, or a list of inventory items, or pluggable enemy AI profiles. We can have those as scriptable objects and share them between scenes, check them in and out of version control. And there's a lot of nice sort of control and flexibility that you have working this way. So a kind of a traditional way of using scriptable objects is to use them as data containers, as I've just described. But another thing that they can do is that they can actually contain functions. And so you can actually have your scriptable objects execute code. Now, one of the things about scriptable objects that is different is they don't receive all the same mono behavior callbacks. So they don't have things like start and update. So a lot of the time, or in this example, the way that they're working is we'll have a mono behavior in the scene, which does use start and update, and that will be calling functions from our scriptable objects. And so we're going to write the mono behavior that will be calling the functions on the scriptable objects and the scriptable object classes themselves. And so here I have an instance of the editor open with the completed project. So I'm just going to show you quickly what is going on here. So I'm going to play my scene, and you'll see we have this super simple character select menu here with the choice between Little Joe or Big Danny. We'll choose Little Joe. And so this is going to drop us into our scene, and you'll see at the bottom of the scene, you'll see in the bottom of the view, we have these two icons, and these are for our two abilities. So if I press fire 1, you'll see we see a little cooldown on the gun ability, and if I press fire 2, it launches a grenade, and we'll see a little cooldown on that as well. Now, the actual shooting content is taken from another set of tutorials, and so the first of those is released now. It's called Let's Try Shooting with Raycasts, and the second will be released soon, which is called Let's Try Shooting with Projectiles. So as you can see, we have our character select, which takes us to our first character. If we choose the second character, we have the same icons, but now we have a green laser with slightly different properties, and we have a missile weapon that we can launch. So the laser weapon has been replaced with the green laser, and the grenade weapon has been replaced with the projectile. So the way that this is achieved is using scriptable objects. So if we look in the scriptable objects folder here, we have scriptable objects for the character, and the character holds an array of abilities which are here. So here's our Raycast 1 ability. So this holds the icon that's going to be displayed, the sound that's going to be played, the base cooldown, the gun damage, the weapon range, the hit force that'll be applied when it hits something, and the laser's color. And then if we want to have a second instance of that, so this is our pink laser, here we have our green laser, right, which has slightly different cooldown, higher damage, range, lower force, and a different color, right? And so the idea is that we could create multiple variants on this raycast weapon, for example, and store them as assets in our project because we're using scriptable objects, right? And we're doing the same thing for the projectiles. Here's projectile 1. This launches the grenade. Projectile 2 launches the missile. And so if we look, what we're doing is we're just, when we choose the character, we're just selecting a character from our array of characters here, and then the character tells our player controller what abilities to use, right? So the goal of this is to make an ability system which is sort of quite flexible and extendable, and where you can kind of plug and play different abilities. This is useful if you're working with, for example, a game designer who maybe is not a strong programmer. You can give them these kind of scriptable objects and say, just make copies of them and change the properties, and then we'll just slot them in. And also, it's just a nice way to keep things organized. It works nicely with version control. Each of these is just an object. You can check into version control. It's not a prefab. So what I'm going to do is let us close the complete version, and we will not save. And then here is the incomplete version. So in the incomplete version, we have just our player controller can walk around. The shooting is currently disabled, but we do have on our FPS controller here, which has the camera and then a gun child object, we do have these projectile shoot triggerable and raycast shoot triggerable scripts. Now, these scripts are actually kind of adapted from another tutorial, and they're not really the point of this training. I will give you a super quick walk through them, but if you're interested in learning more detail about how the raycast, the laser-like effect works, please check out our recently published tutorial, Let's Try Shooting with Raycasts. That's really walks through that in detail over about half an hour. Since that's not the focus, I'll just do a really quick speed through it later on. But basically, these are the mono behaviors that are going to actually do the raycast and draw the line and stuff, but we are going to control them from via our scriptable objects and hold all the data about their stats and their colors and all that stuff in the scriptable objects. So these are already in the scene. We have the FPS controller in the scene, but nothing else. So what I'm going to do is I'm going to start by creating our first class. Let me just take a quick look at the chat before I plunge in. Yeah, somebody points out, don't get confused, you can't use scriptable objects to store runtime generated data. That's true. You can't write into them at runtime. But one of the really nice, useful things about them is that they don't reset when you exit play mode like things in the scene do, right? So you can tweak values, exit play mode, and your changes will persist because it's an asset. So, and then the other thing that I just want to say, I was sort of inspired to do this training by a talk given by Richard Fine, who's a fellow Unity employee at Unite 16 in Amsterdam, called Overthrowing the Mono Behavior Tyranny with the Glorious Scriptable Object Revolution, which is kind of a funny title, but it's a really terrific talk talking about many different aspects of scriptable objects and workflow and what they're good at and what they're not. And so if you want to kind of get a scriptable object primer, I strongly recommend you check that out. I'm going to be showing an example of them in use as opposed to giving you like a full class about what they are and everything. But I think it will be interesting and useful. So let's begin. So we're going to create our first class. We're going to create in our scripts folder a new C# script, and I'm going to call this ability. Now this is going to be, let's expand it. this is not going to derive from mono behavior, right? By default, everything derives from mono behavior in Unity, but this will not. This will derive from scriptable object, right? So now start and update, these kind of normal callbacks we're used to using, will not be called. These functions can sit there. We can have a function called start and update, but they won't be called automatically by Unity. So we're not actually going to use those. We're going to delete them. And one of the other changes that we're going to make here is this is going to be what's called an abstract class. Now, the reason that we're making this as an abstract, class is because we're going to have functions in it which have no implementation. And the reason for this is that we are going to have later, this is going to be our base class, and then we're going to create a raycast ability and a projectile ability, right? Both of them are going to need to implement the functions that we're going to outline here differently, right? So by making it an abstract class, we make that possible. So we have these empty functions that we can then fill in, that we can then specify their implementation in the base classes. So we're also going to have some public variables that are going to appear in the inspector that we can edit. So we're going to have a public string called a name, and this will be equal to new ability. We'll initialize it to new ability. We'll have a public sprite called a sprite, and that is going to be set in the inspector. A is just short for ability. I just didn't want to type ability sprite, ability name a million times. We're going to have a public audio clip called a sound, which we'll set in the inspector as well. We're going to have a public float called a base cooldown. And this is going to be the base cooldown time in seconds, which we'll initialize to 1. And then we're going to have our two abstract functions. So we're going to have a public abstract function that returns void called initialize, right? And this is going to kind of replace our awake or start callbacks that we would use normally to do things like set up references in our other classes. We're going to do that using initialize. And then we're going to have a public abstract function that returns void called, not initialize again, this is going to be called trigger ability, right? So the trigger ability is a kind of an easy one to understand. Every ability is going to need to be triggerable, right? We're going to need to be able to fire our gun to launch our projectile, but the way that what they're going to do when they trigger is going to be different, right? And so this is a kind of a good example of a way to use an abstract class and an abstract function that we're not going to specify what they do in the base class. We're going to specify that in the child class. So let's save that. That's all that's going to be in there, right? And now, and it's worth noting, right? Ability is never going to be instantiated. That's another aspect of it being abstract. We're never going to have a copy of ability in the hierarchy. We're never going to make an ability scriptable object. We're only going to make things which derive from it. So the first thing which is going to derive from it is going to be our raycast ability. So let's go ahead and create a new C# script and call it raycast ability. And this now is going to derive from ability, right? So it's not a mono behavior, it's an ability. And so that means it has all of these variables and it's going to implement these two functions, right? Now, the other thing that we're going to do here is that we are going to add, and in addition to, so it's an ability, and because ability is a scriptable object, this in turn is a scriptable object as well, right? Because it inherits from a scriptable object. So because it's a scriptable object, we can add the very handy create asset menu attribute here, specify a menu name, which is going to equal abilities raycast ability. So this is going to allow us to create instances of this as an asset in using the create menu in Unity. So I'll show you how to do that in a second, but first let's get this written out. So we're going to delete start and update, right? Because we're not going to use them. And then we're just going to add some public fields. So remember, it has all the fields that ability has, all the variables that ability has, but it's also going to have some specific to what it does, right? So it's going to have a variable for gun damage, which is an int, how much damage the gun will do. We'll initialize that to 1. It's going to have a float called weapon range, which we'll initialize to 50. Put an F because it's a float. We are going to have a public float called hit force, which is going to be equal to, let's make it 100. That's going to be how much physics force is going to be applied when it gets hit, when it shoots something. And then we're going to have a public color called laser color, which we're going to initialize to color.white. Now, we are also going to have a private variable of the type raycast shoot triggerable called RC shoot, right? So this is our mono behavior that actually does the shooting code. It does the raycast and it draws the line for the laser and it applies the damage and so on, right? But it's going to use the values stored in the scriptable object. And so then we are going to implement those functions that were abstract in ability. So now we're going to say public override, right? Meaning we're going to override the previous implementation initialize. And this is also going to take a game object called obj. So the game object that we're passing in is going to be the object, in this case, that has the raycast shoot triggerable, the weapon. And so we're going to use this to get a reference to it. So we're going to say RC shoot equals obj dot get component raycast shoot triggerable. So we're going to pass that in here so that we can then get a reference to that script and store it in RC shoot. And then we're going to call RC shoot dot initialize. Now I'll give you guys a quick look at RC shoot just so you understand what is in there and what it's doing. So let's take a look at raycast shoot triggerable really fast. So here we have public variables for damage, range, and hit force. Notice that we're using hide and inspector here. I don't want my game designer to go down to the gun and try to enter a damage value and be like, oh, why isn't it working? Because it's being overwritten by the scriptable object, right? So I'm hiding that in the inspector so that people don't get confused about where they should be editing that value. It's got a public transform called gun end. That's going to be the spawn point. And that, actually we need to set that. That's going to be set to this gun end game object in the inspector. That's the only thing that we're going to set publicly. And then it's got a private reference for the camera. This is a wait for seconds object for the coroutine that turns the laser on and off. An audio source, actually, which we're not using. We can take that out. This all actually can go. I commented it out, but I forgot to delete it. Boop. Because the audio is going to get played elsewhere. And so then in initialize now, the code that we were doing in when this was a mono behavior before, we were doing this in start, right? Now we're doing it in initialize and we're going to call it from the ability, right? And then previously when this was a mono behavior, we were checking for input in update and checking to see if enough time had elapsed to fire, and then doing our raycast and doing all our shooting code, right? Now I just put that in a public function called fire, which we're going to call from raycast ability, right? So again, for more detail about how all of this raycasting code works and using the line renderer to draw the line and all that stuff, please check out the Let's Try Shooting with Raycast tutorial because it's a little out of scope for this session. Okay, we'll save those changes. And so we're going to be calling that initialize function, right, to get our component references to the different components. And then, now that we've done that, we're going to set the gun damage of our raycast shoot script to equal the value stored in the scriptable object, right? And we're going to do that for weapon range. We're going to do it for hit force, right? So all of those public variables that I showed you their values are going to be set from the scriptable object. And then we're going to say RC shoot.laserline.material. We're just going to add a new material to this, equals new material shader.find unlit color. So I'm basically just adding a new unlit material to the line renderer, and then here I'm going to set the color. So RC shoot.laserline.color .material.color equals laser color, right? So we're going to set the color of the laser. Then all we need to do for triggerability is we're just going to say public override void triggerability RC shoot dot fire. So when we call the triggerability function, it's going to call the fire function of RC shoot in raycast ability because it's overriding the original declaration here, right, in the parent class. But when we call triggerability in, for example, our projectile ability, it's going to do something different, right? And that's kind of at the heart of how this is working. So let's save that. And let me just take a sip of water and look at the chat. So some people talking about hide in inspector. Yeah, the thing about hide in inspector is, in this case, I want to access those values from other scripts, but I don't want people working in the editor to think that they need to set those values in the editor, right? So they do need to be accessible from other classes, but I don't want somebody to think they need to drag and drop things there. Somebody asking about what callbacks scriptable objects receive. They receive on enable, on disable, and on destroy, and that's it. So if you want to hook it up to another, that's kind of why if you want to hook them into the sort of mono behavior ecosystem, you can write a mono behavior that gets the callback that you want and then pass that into the scriptable object. Yeah, somebody's saying you can also create a custom editor for them. You totally can. Yeah, I'm trying to keep this a little more on the simpler side and not delve into the editor scripting. But yeah, if you have a bunch of complex stuff there, making a custom editor is probably a really good idea and is definitely recommended. Let's just see if there's anything else. Yeah, create asset menu is recent. I think it's 5.3 or 5.2. Oh, somebody asking whether it should be raycast with an uppercase C. It actually should be raycast with a lowercase c. That's a typo. So now that we have, let's make sure that compiles, no errors, very good. Now that we've created that raycast ability, we can make an instance of it, right? So I'm going to highlight my scriptable object folder to create it in there, and then I'm going to go assets, create. Notice we now have this abilities menu at the top of our create, and then we have raycast ability as a choice. So I'm going to click that to create a new raycast ability. I'm going to call this, let's call it pink laser. And let's populate these fields. So the name is not actually used anywhere, but you know, could be. The name is going to be pink laser. The sprite will be this, where is it? There's this turret sprite that I had. GUI turret marker. This is actually from the VR sample assets. I'm just reusing some content here. That's going to be the icon that's going to appear on screen. The audio clip that's going to play when we shoot is going to be this shooter weapon audio clip. Base cooldown is 1. That's fine. Damage is 1. Weapon range is 50. Hit force is 100. That's all fine. Let's change the laser color to be a lovely hot pink. And now we've got our pink laser. Now let's say we wanted to create a green laser. All we have to do is just duplicate the pink laser, or obviously just create a new one, but I'm going to reuse some of the data. And now I'll change the name to green laser. green laser. We can use a different sound. We'll use this other laser sound. And maybe the cooldown is longer, right? Maybe it takes 2 seconds, but maybe it deals 3 damage. The range is longer and the force is higher. And then obviously the color is going to be a lovely lime green. So the idea is that we can just create as many of these as we want, and then we're going to drag and drop them into our ability cooldown controller script, which I'm going to create next. But first, we're going to need a little bit of simple UI to show us visually what's going on. So, lasers are the future. That's a good question. Is it laser? I think we write it with a Z. Well, I'm going to write it with a Z. I'm just going to write it with a Z because this is my training. Let's go ahead and just create this UI. So I'm going to collapse this. Let's create a UI image, right? So I'm going game object UI image, which is going to create a lovely white box for us in the lower left hand of the screen. And what we're going to do is in the rect transform, we're going to click on the anchor presets and hold Alt or Option to anchor it to the lower middle of the screen. And then in the image component, let's name it, right? This will be the canvas will be called UI, and the image will be called ability icon. And then what I'm going to do, the default source image in the image component here is going to be set to this UI sprite image. That's just one of the defaults that comes by default in the project. Now, the reason I'm doing this is because I want to set the image type to filled. And setting it to filled it makes it look a little janky here, but what it allows me to do is adjust the fill amount, right? So we can do this radial, the default is this radial 360 fill method. And so it allows us to do this. Now, we're not actually going to do it on the main icon. We're going to do it on a dark mask we're going to put on top of it. So let's make that. So what I'm going to do is I'm just going to duplicate this ability icon. I'm using Control D on Windows. It's Command D on Mac. And we're going to call this dark mask. And then we're just going to set the color to black and the alpha to, around 140, just to be about halfway visible. Then, now when we adjust the fill amount, we get this nice grayed out sort of clock wipe to show us when our ability is available. Now, important to note, right, we're never going to see these placeholder images at runtime, right? Those are going to get replaced by, in this case, the laser turret icon. And then we're just going to add a quick UI text as well. We're going to go to game object UI text, and this will be called cooldown text. And this is going to display the time left in seconds. And let's make both of these a child of ability icon. And then I'm just going to center this. Alt-click to set the position and the anchor preset, center it on its parent, and then we're going to center the text as well. And we'll just put some placeholder text in here, CD for cooldown. Let's make it a little bigger, make it 18, and we'll make it bold. All right, so that is good for now with the UI. So now we need a script which is going to control this UI. All right, so I'm going to highlight the ability icon, add a component. This one is going to be called ability cooldown. So it's going to be a new script, create and add. So I'm creating a new script attached to the ability icon. And let's double click to open it for editing. And before I continue, let me just take a look at the chat. Spellcheck is complaining about laser. Well, tough. Tough. That's funny. Yeah, this is the future. So we spell laser with a Z. Very good. Okay, so ability cooldown is in fact going to be a mono behavior, right? We're going to use start and update in ability cooldown. And this is going to be one of the ways that we're going to hook back into the mono behavior ecosystem. And so, tweedledee, let's go down. Let me just pull up my notes here for this class. Okay, so the first thing that we're going to do is we're going to add using UnityEngine.ui. And we are, so that we can use members of the UI namespace like image and text. And then we're going to add some public variables. So we're going to have a public string called ability button axis name, which is nice and long. And that's going to be equal to fire1. So this is so that we can set what input axis from the input manager, our ability cooldown, what button is going to be triggering our ability from the input manager. We're going to do that based on the string. Then we're going to have a public image called dark mask, right? That's our dark mask. We're going to use this to manipulate the fill. And then we're going to have a public text called cooldown text display. That's just going to be the text object that we're going to use to show the time left in seconds before the cooldown is ready. Now, this is a step that we're going to do a little bit differently. And I'll explain. So we're going to use the serialized field attribute, and we're going to have a private ability called ability, right? So I need to do this so that by the time we get to the halfway point of the two trainings, I can still demo it for you. So I need to be able to drag and drop an ability in the inspector, but I actually want the ability ultimately to be private because we're going to set it by calling the initialize function, not another way. So for now, we're going to use the serialized field attribute to make it so that we can set a private field in the inspector, but later we could take it away, or you could just leave it. But anyway, just a kind of a note there, because this is something that I'm doing that I wouldn't normally do if I was just writing this straight through, but so that I can demo it in two parts, I need to make these assignable from the inspector. And we're going to do the same with the private game object weapon holder. Weapon holder will eventually get set by the character select menu, but for now we need to set it in the inspector. Weapon holder is the gun that holds the raycast, shoot triggerable, and projectile triggerable scripts so that we can get a reference to those scripts from here. And then, or so that we can pass it actually to our ability. So then we're going to have a private image called my button image. That's going to be the icon. We're going to have a private audio source called ability source. This is going to be what's going to play the sounds, and this is actually going to be attached to the UI. And let's just add that now so I don't forget to do it later. This is going to be attached to the ability icon. Each one is going to have their own audio source, and so I'm just going to do add component audio source. We don't need to, I'm going to turn off play on awake. We don't need to specify a clip because the clip is going to get set by the scriptable object. Okay. Now, we are going to have a private float called cooldown duration, right? This is how long our cooldown is going to take, and it's going to be set from the base cooldown in our ability. And then we're going to have a private float called next ready time and a private float called cooldown time left. So next ready time is going to be the next time in seconds when the object is going to come off cooldown. The time left is just going to be used to display our countdown in our UI. And then, so that's it for our variables. Now in start, just delete this comment. In start, we are going to actually call the initialize function of this, but again, we won't do that for the final because it'll get called by the menu. But first, let me declare my initialize function. So again, all of these initialize functions, I'm basically using the way you would often use start or update. I mean, start or on enable or awake to get references and set things up, but I'm just calling them from other classes. So initialize in this case is going to take an ability called selected ability. It's going to take a game object called weapon holder, and we are going to call it in start, again, just for this part of our demo. We'll actually take this out later. So we're going to call initialize, and we're going to pass in ability, which is going to be the value set in the inspector, and weapon holder, which is also going to be set in the inspector. Later, this will get called from our character select class. Okay, so in initialize, we're going to set ability to equal selected ability. We're going to set, which again here is a little funny, but later will make more sense. And then we're going to set my button image to equal get component image, right? So we're going to get a component reference to the image component that's going to display the icon. We're going to get a component reference to ability source, to our audio source. And we are going to we're going to set my button image dot sprite to equal ability dot a sprite, right? So here now we're starting to pull the data out of the scriptable object. So ability is our scriptable object, right? And so we're going to set the sprite of the UI element to the sprite stored in the scriptable object. Then we're going to set dark mask's sprite to the same, so that the mask matches the icon. And then we're going to set cooldown duration to equal ability.abase cooldown. Then we're going to call ability.initialize, right? So we're going to call, in this case, it'll get the component references to everything, set all the values in the various scripts down the chain. All right, so now the final thing that we're going to do here is we are going to call a function called ability ready that we need to declare. And that's just going to be called every time the ability is ready to use. So this is going to be super simple. Private function that returns void called ability ready, no parameters. And all we're going to do here is we're just going to say cooldown text display dot text. No, wait, sorry. Dot enabled equals false. And dark mask dot enabled equals false. So when the ability is ready to use, the cooldown text and the mask are going to be turned off. And then we're going to call that from the end of initialize, because the first time ability ready, the first time it's initialized, the ability will be immediately ready to use. Okay. Shouldn't I pass something to initialize? Oh yeah, I think I did. I might have missed that. Let me see. Yes, thank you very much. Yes. Twitch Hive Mind for the win. Yes, we're going to pass in weapon holder. Thank you. All right, I'm typing too fast. All right, let me just look at the chat, see if I missed anything else. Okay. Okay. All right. People talking about serialization. I'm not going to get into that. Yes, and then Oscar Ruzzo and Ready Play Games point out that I forgot to pass in my game object, which is very important. All right. This is why this is live. Even if I have notes and the whole script written down next to me, I still make mistakes. All right, so now let's just get our other functions that we're going to call ready, and then we'll write update. So we've got ability ready, which will get called when it's ready. We've got another one called cooldown. And I got an extra brace there. Let's just add some white space so this is not all the way at the bottom of the window. And then in cooldown, so this is just going to get called every frame when we're on cooldown. It's going to be called ultimately from update. So what we're going to do is cooldown time left minus equals time dot delta time. So we're just subtracting the time it took to render the last frame from our total of time left, and we're going to use that to display the time. Then we're just going to say float rounded CD, rounded cooldown equals, we're just going to round it, mathf.round passing cooldown time left. This is just so that we don't get like 1.0056789 long decimal numbers displaying in the UI. It's just going to show us rounded seconds, basically like an integer. And then we are going to set cooldown text display dot text to equal rounded CD dot toString, right? We're just going to set the text of the UI element to that number. And we're going to update dark mask dot fill amount to equal cooldown time left divided by cooldown duration, right? So this is going to give us a number between 0 and 1, which is going to be effectively the percentage of our cooldown duration that has elapsed. And we're going to use that to set the fill amount and update it so that we get that nice clock wiping sort of animation in the UI. The last thing that we're going to call, and these are basically all going to be called from update, but let's just get them ready before we call them, is going to be a private function that returns void called button triggered, right? And this is just going to be the stuff that we're going to do once the player has actually pressed the fire button. So first of all, we're going to set next ready time to equal cooldown duration plus time.time, right? So we're going to say, okay, we just fired. Now the next time we're going to be allowed to fire is going to be 1 second in the future, right? So time.time, the total elapsed time plus cooldown duration. Then we're going to set cooldown time left to equal cooldown duration, right? We're going to reset cooldown time left to be the full cooldown. Dark mask dot enabled equals true. We're going to turn back on our dark mask. Cooldown text display dot enabled equals true as well. I'm going to turn back on our cooldown text. What is it? Ability source dot clip. So we're going to set the clip of ability source to ability dot a sound. So we're going to set the audio source clip to the sound, to the audio clip that's stored in the scriptable object. And then we are going to call ability source dot play. We're going to play the sound. And finally, we're actually going to call ability dot trigger ability, right? So that is going to, in this case, call this function here, which in turn is going to call the fire function of raycast shoot, right? So this is what's going to happen when the fire button is actually pressed. Okay, now that those are all ready, we can call them from update. So in update, we're going to have a Boolean called cooldown complete, and that's going to be equal to time.time is greater than next ready time. So basically, if more time has elapsed than next ready time, cooldown complete is going to be true. And then we're just going to say if cooldown complete is true, so meaning if the ability is off cooldown, it's ready to use, we're going to call ability ready because it is now ready. And then we're going to check if it's both ready and input.getButtonDown ability button access name. So the ability button specified by ability button access name is pressed that frame. And then we're going to call button triggered, meaning it's time to actually trigger off our ability. And if not, else, then we are going to increment our cooldown, right? So this is all going to call from update. So it's checking for the input. And then if it's not ready and the input button and the fire button is not pressed, then we are, oh wait, no, I think I made that wrong. Nope, this is not supposed to be there. Durr. Oh my gosh, such fails. At least I caught that one myself. There we go. Cooldown. Durr. Alrighty. Live coding. It's happening. It's going down. Okay, I hate the way MonoDevelop makes this stuff look. Okay, better. Okay, so basically if the cooldown is not complete, we're going to continue calling cooldown, right? Decrementing cooldown time left and updating the fill amount and so on. If the cooldown is complete, we're going to check to see if the button was pressed, and we're going to call button triggered. Okay, save. We're getting to the end here. Let me save. So now jump back over to the editor. No compile errors. Let's put this ability cooldown in our scripts folder just to keep things neat and tidy. And now on our ability icon object, we've got these fields that we need to set, right? So let's set dark mask to our dark mask, cooldown text to cooldown text. The ability, remember, this will get set later via script, but for now we're doing it as a temporary thing, is going to take a scriptable object, laser with a Z, and the weapon holder is going to be, again, set in the inspector here. This is going to be the gun object. It's the object that has the projectile shoot triggerable and the raycast shoot triggerable on them. But later we'll pass that in from the character select menu in the next training session in 2 weeks. And so that should be good. Let's give it a test. So now if I play my scene, there's my little turret icon that appears. A little hard to see on the white background. And then, boom, boom. I can shoot. I can cool down. And if I want to change it, all I have to do is drag in my pink laser, jump back, and there we have it. So the thing I like about this is that our abilities are kind of quite encapsulated and we can swap them in and out. Now, let me take a couple of questions first before I continue, but then we'll do really quickly projectile ability, which is going to be pretty simple, and show how we can just drop that in as well. Game Fails BR asks, can we use Scriptable Object as a database like items or conversations? Is it good or not? It is good. Yes, you can. That's kind of one of the great things to use it for, is as a data container. Now, you could decide whether you wanted to use a scriptable object that had many fields for all the items, or if you wanted to make each item a scriptable object. And that would relate to how you wanted to work in version control, or just how you want to organize your project. But yes, you definitely can. And you can also read and write scriptable objects to JSON, which I don't actually know how to do, but I know is possible. And you can learn more about in Richard Fine's scriptable object talk from Unite that I referenced earlier. All right. C-Strachan asks, could this be used for power-ups in a game? Definitely, yes. This would be a really cool use for power-ups. You could have there's actually, if you look at the scriptable object talk that Richard Fine did, he specifically shows a power-up example. So I would say take a look at that there. The way I would probably set it up is you would need to have if it's an ability that gets activated, you need to have the abilities already set up on the character, so you're just turning them on. But yeah, totally. That would be a great use for it. Let's see. Yeah, guys, if you are wanting to find out when live training is coming, I always put it on my Twitter, which is @MattMirrorFish. And then there is the live training page. I mean, I know we were quiet for like 6 months with this, so obviously it's kind of a surprise that we're popping back up, but there's this one is on the schedule, and then the next one is in 2 weeks on Monday is on the schedule. And yeah, if you follow me on Twitter, you'll see it. And then the Unity Twitter puts it out as well. And obviously, if you subscribe or whatever it's called to the Twitch channel, you'll get emails when we go live. Yeah. Okay. So I'm going to do this next part a little quickly just because we're getting to the end of the hour, but it's pretty simple. So let's say we want to flesh out this system, right? We've got our raycast ability. We want to make a projectile ability. So let's go ahead and create a new C# script. This will be called, you guessed it, Projectile Ability. Double click. And then this is also going to derive from ability, right? It's an ability as well. We're going to lose start and update. And we're going to add the create asset menu attribute so we can make assets of it. Menu name equals abilities projectile ability. Boop. And then we're going to have a couple public fields. We're going to have a public float projectile force, which is going to be equal to 200. Let's make it 500. Actually, 200 was a little weak. We're going to have that's the force that's going to be applied to push the projectile away. We're going to have a public rigid body called projectile. That's going to be the prefab that we're going to spawn and launch. And then we're going to have a private, not raycast, a private projectile shoot triggerable called launcher. And then again, right now, this kind of shows you where the abstract functions, right? So before we had our abstract function initialize and our abstract function trigger ability, now we're going to override them differently in this class. So we're going to have public override void initialize, which again takes a game object called obj. And then we're going to call, or we're just going to set the launcher to equal obj.getComponent projectile shoot triggerable, right? So we're going to get a reference to the launcher attached to the weapon object that we're passing in as a parameter. We're going to set its launcher.projectile force equals projectile, can't type, equals projectile force launcher dot projectile equals projectile, right? And then that's it. And then we're going to just call public override void trigger ability. And that is just going to call launcher.launch. So the launcher script, I'll just show you super fast. It's really simple. It just clones the prefab and adds force to it to launch it. And then the prefab as a script to make it explode and do damage and so on. And I will cover this stuff in a future tutorial called Let's Try Shooting with Projectiles. Okay. And that's it, right? So save. And let's highlight our scriptable object folder to make it in there. And we're going to go assets, create, abilities, projectile ability, right? So now we have that added. And this one we'll call grenade and grenade. And let's set an icon for it. I'm going to use this, where is it? This little, sort of looks like a grenade, that clock. And we're going to add an explosion, shell explosion sound. It's the shell explosion from tanks. The base cooldown, let's make it 3. Projectile force, 500 is fine. And then the projectile is going to be the prefab projectile grenade, right? And then if we want to make a missile as well, let's just duplicate this. Command D to duplicate, or Control D. Change the name. Let's make the cooldown shorter. Make the force 400. Doesn't really matter. And then the prefab will be the missile prefab, right? So now I'm just going to add a copy of ability icon. And so this is where it gets cool, right? If we needed a lot of these, we could even instantiate these via script. I'm I'm just going to duplicate it. Again, Control D. Just move it over a little bit on the X. A little sloppy, but that's fine. And this will be ability icon 2. And then here now, again, remember this will be set by script in our next training, but right now we're just going to drag it in. I'll just drag in the grenade, and that's all I need to do, right? Now I have my scriptable object. I just drop it in there or set it by a script. Hit play. It pulls out the icon, right, as you can see. And then if I push fire 2, oh, whoops, you see that? Push fire 1, and it shoots both of them because I forgot to change this ability button access to fire 2. Derp. There we go. Boom. It's got its cooldown, does its explosion. Hooray! And so, yeah, that is the basic concept for today. So for the next training, what we're going to show is kind of hooking this into a character select system where we're going to create a character scriptable object that's going to hold an array of abilities with a menu where you pick which character you want to load from the menu, and it's going to set all the abilities correctly, pull all their icons and everything else, and really give you a lot of flexibility. So be sure to tune in for that in 2 weeks. And if you're watching on YouTube, hopefully the archive will be up when you're watching this. And yeah, thanks a lot for watching. And I'm going to take some questions from chat. Oh, yes, my Twitter is at Matt, M-A-T-T. Here, I'll just put it in the chat. At Matt Mirafish, but I'll just type it. And of course, that is my official. Here, hold on. Actually, I can put it on screen. I'll show everybody's Twitter because there's a few of us. There we go. That's the official Unity Twitter. That's Adam is the Ant Ranch. Will is at Will Goldstone. Me at Matt Mirafish, and then at Mike Geig, who actually sadly doesn't do live training with us anymore, but he's also awesome. And on Twitter, and then of course at Unity 3D, and the Unity Twitter account did tweet this out and stuff. So if you're following them, you will get it as well. All right, so let's see. With my scriptable object data model question, I was referencing in a state machine scenario, like if your player has a state machine with idle, run, and jump state, and a data model that holds run speed and jump height, could an SO hold that instead? Oh, definitely. Yeah, if you just need to hold some fields like run speed and jump height, definitely. Yeah, if it's just like some numbers, easy. Yeah, and the cool thing about it is that you can edit it at runtime and it won't get reset when you exit play mode, which I really like about it. Scale Z says, repost my question. Since you skipped it, is it possible to nest SOs? I tried it using asset database.add object asset, but only got weird and glitchy results. With nesting, I mean something like the sprites are arranged within a texture object. Short answer is I don't know. But I also kind of wonder, like, why don't you just put the sprites in an array or a list in the scriptable object? Or maybe you want to write like a little custom editor to display them. But I think that just having them in some kind of a collection in the scriptable object would maybe be fine, unless maybe I'm misunderstanding. Yeah, MDK Piage, sorry if I pronounced that wrong, says if you want to save runtime objects, I think you can do it by means of binary formatter. You definitely can. That's actually what I do. I have, like, in my personal project, I have a class that holds like all the data about how many enemies the player killed and stuff, and I use the binary formatter to write that to disk and then reload it every time the game starts and stops. For the little tiny bits of data, you can do it with player prefs if it's just like a few numbers, but for bigger chunks of stuff, the binary formatter definitely works. Yeah, you could do the good thing about binary formatter is it's not human readable, so that it's not like easy for people to just go and edit the values. But yeah, XML, if you don't mind about that, is fine as well. Yeah, binary formatter for game saves, I think, is pretty solid. regarding nesting. See this talk, Serialization in Depth with Tim Cooper, a Unite Nordic 2000 can't talk. A Unite Nordic 2013 presentation. I have to check that out, actually. Sounds interesting. No. Yeah, Giblote. I think that's the one I'm talking about. I think that's Richard's talk where he talks about using scriptable objects as a default template for an object and then write and read the info to JSON. That's Richard Fine's talk, I believe. It's good stuff. Woo! All right, guys. Thanks so much for coming out. Welcome to everybody who's new. Welcome back to all the regulars. Great to see you all again. Great to be back. I'm going to cut my mic off. I'll leave the stream up for a few minutes and leave the chat open. If you guys have further questions there, I can type them in. And yeah, thanks again.